So we're going to go over our very last section of Chapter 4. So next week we're going to have some reviews in our Chapter 4 test on Thursday. 4.8 isn't anything new. It's really just using all of the stuff that you've learned off of those trig functions and just applying them to some problems. We're just going to do some problem solving. We're going to be looking at right triangles. You're going to be using those trig identities, and you can also use Pythagorean theorem. So it's all stuff that we've went through. It's just we're just going to get a little more fancy with it, right? So I know that the first kind of questions they kind of put out there for you guys, they just kind of give you the whole right triangle, right? They're going to say, I don't know, this is like 24 degrees, and this is, give me a number. 9. And this is 9, right? And then you got to find all the sides and all the angles, right? So most likely you're going to use trig to start with to figure out one of the other sides. You can continue using trig, or you can use Pythagorean theorem. How would you figure out this angle up here? Absolutely, yep. It's the triangle adds up to 180, so just 180 minus 90 minus 24 is going to give you that one, right? After you figured out one of the other sides, let's just say for poops and giggles without doing the problem, let's say like this ended up being 12, right? To figure out the hypotenuse, you can either use one of your trig identities, your trig functions, or you could use Pythagorean theorem, right? So those are all back from all the little good garbage that we've done. So I think you guys are good on those. So I'm
trig functions are those
yes. Yes. Well,
like the
yeah,
tangent,
or you can just
cotangent, secant. Okay.
Right, or you can just use sine, cosine, tangent, right? You can use the secant on them, but either way. Yep.
We won't have to do like angle, side angle, all those from like geo.
Nah, not today. Not today. Right. Or we don't need to prove any triangles congruent or similar right now. Yes, exactly. Yep. All right. So getting a little fancier, because you guys are the advanced little, trig pre-calc students. They like to give you guys some little pictures like this that make you kind of go, what? But then as we get through them, we're like, oh, these aren't so bad, right? My little square in the corner is telling me that I have a 90-degree angle. And what kind of shape?
Right triangle.
A right triangle, right? So now when I look up here, how many right triangles do you see?
2.
I see 2, and you see 2, right? So we have the smaller, right triangle, okay? And then to the right, because I can't lift my pen up yet, to the right, what's our angle going to be, that rightmost angle?
Oh, 20.
The 28 degrees, right? So, and then we know we got 90 degrees. And we know that the base of that triangle is that 400. And really, we need to find this guy over here, right? So we can use trig to find out that little guy, right?
Are we trying for both triangles?
Well, and then the second triangle is this big one, right? And we know it's a 90-degree angle. We know that that base is 400. And then now this angle here is that 40, right? So then we could use trig again, and we could figure out this whole entire side. So we only need this little tiny piece. So if we figured out the whole side, and we figured out this side, we could subtract those two and figure out what our x is, right? So sometimes it's easier if you guys draw out the 2 triangles and then figure out what you need to know. So if we start with that small little triangle, I'll draw it up here, right? And then we knew it was a right angle. We knew that this was 28 degrees.
Is this 4.8?
4.8, yep. And then we knew that that base was 400. So what side do you think we want to find? Do we want to find this guy or this guy? So do we want to find A or B?
A.
We want to find A, right? So I'm just going to throw it as an X for the fun of it, right? So what do we think we could do to figure out that side?
Just cosine 28.
Cosine. So cosine stands for what over what?
Opposite over adjacent.
Opposite over adjacent? That's opposite.
Opposite over hypotenuse.
Yeah. Cosine is adjacent over hypotenuse, right? And we don't know anything about our hypotenuse. Tangent? Tangent's what over what?
Opposite over adjacent.
Opposite over adjacent. So there's our opposite and there's our adjacent, right? So the tangent of what angle? 28 equals opposite over adjacent. So to solve this, you can put it over a fraction if it makes you warm and fuzzy, right? So then you got two fractions that are equal to each other, so they're proportionate. Proportions are equal numerator to denominator times denominator, or cross multiply. So we get what? X equals 400 times the tangent of 28. So we're going to put that into our calculator. But when it comes to our calculator, we know we have two modes. We got degree modes and radian modes. What should we be in? Why should we be in degree mode? Yeah, they're giving us the degrees, right? So we need to be in degree mode. Yes.
How did I not know that on decimals? If you press the radian button, it puts it in degrees.
It's a toggle. Yeah, that little
What
toggle
is that?
switch.
That's like pushing an on button on and it turns off. Like you don't, like it's reversed for no reason.
No, it's a toggle when you push it. If it says
I didn't know that.
if it says RAD, that would be radian.
Yeah, so
And then you click it, toggle means you go to the other side, and then it shows degree. And then if it shows degree, then you're in degree mode.
Oh,
Yeah.
that makes no sense.
So I know you guys put this into your fancy dancy calculator to make sure you guys are in the right mode. And we end up getting, we're just going to do it to the nearest whole number just to keep it simple for our example. And what are we going to get? $212? $212 or $213?
212.6, so I need to do
213, yep. So 213, right? So on our big picture, we know that from here to here, right, that's 213, right? So then we got another triangle up here. We got this big triangle, right? So if it helps, if you need to, draw out the big triangle. Look, and I'll even make it a little bit bigger. Okay. We knew it was 90 degrees. We knew it was 400. Our angle on the bottom is going to be 40 degrees. And we need to find out this side. Okay. Sine, cosine, or tangent? Tangent. All right. So what do we got now? The tangent of 40 equals x over 400. So x is going to equal 400 times the tangent of 40. We're going to put that little cute guy into our fancy dancy calculator. Nearest whole number we get, oops, that's good. Let me put that up a little bit. Yep, 336. So that's telling us the whole big triangle, so from here all the way down to the bottom, is 336. So how are we going to find out just that little tiny piece?
Subtract.
Yeah, you're going to subtract them, right? So to find this one, you're just going to do 336 minus 213. And what do we get? 123. Yep. So this is 123. Yep. So our x is 123. So when I work on these problems, I always look for finding my two triangles that I'm talking about. Which two triangles that we're looking at, and then figuring out like which side it is that I need to find out. Does that make sense? Because they can move this all the way around, right? Sound good? All right. I know some of you guys love English. I know some of you guys love the ocean and the beach. So You love both, right? So perfect problem, right? So they want you guys to be able to like draw pictures and be able to figure out like what they're talking about and all of these good little terminologies in here. So we got a 200-foot cliff. Everybody know what a cliff is? Right, not the Cliff Bar. So we got a cliff, and that cliff has drops vertically into the ocean. Vertically is which way? Up and down, yep, into the ocean. If the angle of elevation, we got no elevation and depression, from a ship to the top of the cliff is 22.3 degrees, how far offshore to the nearest foot is the ship? So you can either just draw the triangle or you can draw pretty pictures, right? So we're gonna draw a triangle, right? So we have a cliff that drops vertically into the ocean. And we said vertically was going up and down, right? So up and down. There's my cliff, and my cliff goes into the ocean, right? So where do you think the ocean's gonna be? On the bottom, right? And in the perfect world, our straight cliff and our ocean are gonna make a 90-degree angle, right? And then we can connect a line from the top of our cliff down to our ocean. Right, and that, and that makes a perfect little right triangle, right? And we can fill in that this here was 200 feet. Where are we at next? Oh, we have a boat. We have a ship, right? Where's our ship gonna be? Do you think our ship is gonna be hanging here against the cliff, getting broken? Do you think our ship is up here on the top of the cliff? No. Is our ship out here in the ocean? Yeah. So we can even draw a little, hey man, little ship out there, right? Thank you, thank you. And it says that the angle of elevation from the ship to the top of the cliff is 22.3 degrees. So we got to think of that word elevation. Elevation means rising or looking up, right? So I got to figure out which one's going to be my elevation or looking up. So I sit there and go, okay, if I'm looking straight on the horizon and I want to look up, then I kind of make my little angle. So I know that this guy is going to be my 22.3 degrees. For poops and giggles, if I was standing up here on the cliff and I was looking down to my boat, what would that be called? Angle of... Yeah, what happens when you're really, really sad? Depression. Yep, so if you're looking down, it would be a depression. If you push into Play-Doh and you make a little hole, you made a depression, right? So depression is going down. But we're not up there today. And they want to find out how far offshore to the nearest foot is the ship. So are we looking for A or B? B, right? Because remember this was our... How far offshore? So if you're offshore, you're in the ocean, right?
Yeah, but I just would have thought that maybe because I was thinking I was like in town.
This would be how far, if you wanted to, if you were, what's the pirate's name? Jack Sparrow. If you were Jack Sparrow and you had to jump off of the cliff to get to the boat, a little zip line, how long of a zip line do you need to get from the boat to the cliff, right? Here we got to swim from...
Not really the length of the zip line.
No, because, well... True, because he's going to land in the water, and then they're going to pick him up off of then he's going to hold onto the anchor, and they're going to lift the anchor, and he's going to be, in his pirate pose.
Pirates of the Caribbean ride at Disney World was on
Right, it is, exactly. All right. So we got to find this guy down here, right? All right. So what are we going to do to find that guy? I'm gonna do tangent again, right? I have a really bad degree symbol, it almost looks like. Uh-oh, am I running out of time?
Yeah.
Uh-oh, alright, so the tangent of
22.3.
22.3 equals
200.
200 over x, right? If you need to, make it into a happy little fraction, so we can do numerator times denominator. So 200 equals x times the tangent of 22.3. We're going to divide both sides, so what do we get? 200 over the tangent of 22.3. So what do we get?
X equals 488.
What did you get? Yeah, I have like 487.65. So if I did it to the nearest whole number, it would be the nearest foot? 488 feet, yep. Yep. So make sure we're reading our directions so we know proper placement of our decimals. Because I want to say on the homework it says like your sides are 2 places past the decimal, and your angles I think are whole angles.